Hi, hello everybody, my dear NEET and IIT JEE mains aspirants, CBSE students, long-term, short-term students. Thanks for joining for us. Welcome to BMS Academy of GNEET Physics. This is Mr. BHANU MOORTHY Sharma, Senior Physics Faculty Member, Tuition Master, having 30 years of teaching experience. I am conducting online classes, offline classes, coaching classes for NEET short-term students, long-term students, and IIT short-term students and long-term students. Well, in the last 2 weeks, I presented 2 video classes on kinematics, a chapter. I explained some fantastic concepts on motion under gravity as well as projectile motion. In the last 2 video classes, I explained those. Very good response is coming from the students and parents. Thanks for watching my video classes. Yeah, in this video class, number 3, I want to present some beautiful concepts from second year physics chapter, that is dual nature of matter. The concept is photoelectric effect. Okay, let us start now. When monochromatic light this is the source of light. When monochromatic light of wavelength, the lambda and frequency nu and energy E. So they, for example, E equal to h nu, E equals to hc by lambda, we can write. So when a monochromatic light coming from the source is allowed to fall on alkali metal surface. This is alkali metal surface I am drawing here. So which contains number of atoms here, alkali metal atoms, say sodium, potassium, lithium, like that. So what is happening? Incident light is having a group of photons, tiny particles, invisible particles. Okay, so when incident light containing photons strikes a metal surface, due to collision between photons and valence electrons in the atoms of metal surface, the valence electrons absorb some energy from the incident light and gets emitted. Such electrons are called as, I am representing here, photoelectrons. My dear students, NEET aspirants and IIT aspirants, very good concept in this chapter, which we are expecting in NEET entrance as well as IIT entrance. Such photoelectrons have considerable kinetic energy K equals to half mv square, where mass m is mass of electron, v is velocity of electron. Now, Einstein explained that he observed a point that the total incident energy is always greater than kinetic energy of emitted photoelectron. Based on this observation, Einstein framed one equation. Total energy minus kinetic energy of emitted electron, neither be created nor be destroyed. This difference between the energies is in the form of work function, W, work function of the metal. Work function means it is the minimum energy required to the metal surface in extracting electrons, in removing electrons from its outer surface. So that is work function. Work function formulas I am writing here, h nu naught and hc by lambda naught. Nu naught for threshold frequency, which is the lowest frequency at which and below which no electron comes out from the metal, and the lambda naught is threshold wavelength. It is a maximum possible wavelength of light at which and above which no electron releases from the surface. Okay, so these are the formulas for work function. Now we can substitute here. So E minus K equals to W means H nu Hc by lambda, what we can write. So equals to K plus W, or K is equals to E minus W. We can frame so many equations from this. So first equation is what? K, kinetic energy formulas I am framing. So E for H nu minus W. Second formula for Einstein's photoelectric equation is H nu minus H nu naught. Third formula, Hc by lambda minus W, or W formula we can write kinetic energy Hc by lambda minus Hc by lambda naught. Okay, these are the expressions for Einstein's photoelectric equations. Now, very beautiful concept in this chapter it is application of law of conservation of energy. Total energy neither be created nor be destroyed. So the total energy of monochromatic light is divided into two parts. Now, one is in the form of work function, another one is in the form of kinetic energy of emitted electron, right? Now, here kinetic energy half mv square. Due to collisions between electrons, valence electrons and photons. Okay, these collisions are elastic collisions. They may ask this question in NEET as well as IIT. What type of collisions take place in the case of photoelectric effect? So elastic collisions, because they are elementary particles, photons are minute particles, valence electrons are elementary particles. So among elementary particles, elastic collision takes place. Okay, so that's why velocity, there is no that much of that, there is not it's not that much of difference between the velocity after collision and before collision, right? My dear students, two important applications I am going to explain in this case. So, for example, first wave metal plate is here. Its work function is 2 electron volts. Now, a light of wavelength lambda 1 is falling on the metal surface. Then kinetic energy of emitted electron is K1. On the same metal of work function 2 electron volts, because if metal is same, work function is same, because work function depends on nature of the material. So, different metals have different work functions because different covalent bonds are present in different metals. Atomic structures are different. To collapse those covalent bonds, to break those covalent bonds in different metals, different energies are required. That is the reason why W is different for different materials. Now, another monochromatic light of wavelength lambda 2 is falling on the same metal, then electrons release with another kinetic energy K2. In examination, what they will ask, what is the ratio of the kinetic energies in the two cases? So K1 by K2, what I can write, Hc by lambda 1 minus W divided by Hc by lambda 2 minus W, where Hc value 12,400, Hc value 12,400 we can substitute there, provided wavelength is in angstrom. Okay, so W is given there 2 electron volts, Hc value 12,400, lambda 1, lambda 2 values they will mention in the examination. In the first case, lambda 1, say for example 6,000 angstrom. In the second case, wavelength is 5,000 angstrom. Like that, wavelengths will be mentioned there. You can substitute. Finally, you will get the ratio of kinetic energies. My dear students, instead of wavelengths, if frequencies are given to you, how can you compare the kinetic energies of photoelectrons? So that is H nu 1 minus W divided by H nu 2 minus W. Where W, according to the situation, you can mention H nu naught or Hc by lambda naught if the values are given in the problem. Okay, if work function is directly mentioned, you can enter its value directly. Otherwise, H nu naught or Hc by lambda naught you can substitute. So, my dear students, this is the information regarding photoelectric effect. Now, how they are going to ask about logical questions now. Now, let us discuss logical questions in photoelectric effects. Once upon a time, they asked in NEET entrance examination about these logical questions. What are those? Conditions. Now I am mentioning conditions for photoelectric effects. Photoelectric effects. What are the conditions? Number one, incident light wavelength should be less than threshold wavelength for metal. Then only photoelectron releases from the surface. Second one is frequency of incident light should be greater than threshold frequency. Then only electron will be released from the metal. Okay, under these conditions only photoelectric effect is possible, occurs. Now, one example I am giving. On a metal surface whose threshold wavelength is 6000 angstrom, ultraviolet light is allowed to fall. Ultraviolet light is allowed to fall on the metal surface. Does photoelectrons emit from the surface? That is a question. Or does photoelectric effect occur? Then answer I am telling now. Photoelectrons, of course, will be emitted here in this case. Yes, photoelectrons will be emitted. How can you say? Because ultraviolet light is a part of electromagnetic radiation spectrum. Ultraviolet light has a wavelength lambda less than around 4000 angstrom. So you should know this point. They won't mention that value. Okay, just ultraviolet light they will mention. Then we have to understand indirectly that its wavelength is less than around 4000 angstrom. But threshold wavelength for metal is given as 6000 angstrom. So condition number 1 is satisfied. So lambda is less than lambda naught. Therefore, electron definitely will be ejected. The metal receives the sufficient energy and emits electrons from its outermost orbits. Second one, my next question is, suppose if infrared rays are allowed, infrared light is allowed to fall on the metal surface of same threshold wavelength 6000 angstrom. Does photoelectric effect occur or does photoelectrons release? That is the question. Answer is what? This wavelength for infrared radiation, it is also a part of electromagnetic radiation. Its wavelength is greater than or above 8000, near about 8000 angstrom, which is greater than threshold wavelength of the metal. So this condition is violated. So second condition is not satisfied in this case. So the metal does not receive its sufficient energy. So it does not emit electron. No answer. No electron will be ejected from the surface. So beautiful concepts, logical questions from photoelectric effect we can expect. Ratio of kinetic energies formulas you should recognize. Conditions for photoelectric effect you have to know. And elastic collisions I am writing here. Elastic collisions between photons and valence electrons. Okay. So and it's an application of law of conservation of energy, photoelectric effect. It is a quantum concept actually it is. Okay. So this is the information I want to give to you, my dear students. Average students can be cherished in this institution and merit students can improve their rank in the respective entrance examinations. I have 7 batches. Every batch has 20 students only. Okay, so that individual attention will be on each and every student. So that is the specialty of this institution. So in NEET and IIT entrance examinations, the questions are asking based on conceptual numerical problems. So based on concepts and analytical treatment, so they are asking the questions. Okay, so this academy is particularly exclusively conceptual orientation of objective set coaching center. So abundance of concepts are present in this academy, right? So no worries at all. Okay, we have abundance of concepts. So definitely you should join in this institution. There is no other alternate because there is no such type of explanation in any other platform. Thank you, YouTube channel. This is the time I want to recognize. Thanks to YouTube team members, YouTube channel. This is the best platform that you have given to me to express my views and to cherish the students. Okay, so thanks a lot, and thanks to parents and students for watching my video classes regularly. Physics is a tough subject. Actually, it plays an important role in deciding the ranks, okay, in your respective entrance examinations. Your top rank is my top priority. Recognize this point. Take admissions quickly and avail this golden opportunity. So dial my phone number 988-5277-893. I can write here 988-5277-893. Dial to this number directly. You can talk to me regarding admissions. Okay, so already the classes are started. So bye bye, wishing you all the best, my dear NEET and IIT aspirants. Keep on watching my video classes. Now if you like this video, share, subscribe and press bell button, and do viral this video to all your friend circles so that everybody can get awareness in the subject and in getting this good score in entrance examinations. Bye, see you everybody.